Hello students, so today in this lecture I will tell you the protection of carbonyl compounds as acyclic and cyclic dithioacetals and dithioketals. In my previous lecture I explained about the ways of protection of carbonyl compound, different ways of protection of carbonyl compounds and mechanism of protection of carbonyl compounds as a acyclic and cyclic acetal and ketal. So today we will discuss the dithioacetals or dithioacetals and dithioketals. Okay, so suppose if we have a carbonyl compound, okay, then this in presence of acid catalyst, okay, it's in presence of acid catalyst. Suppose if you are taking a if you are taking a thiol, push 2 molecule of RSH. For preparation of acetals or ketals we took 2 molecule of alcohol. Here we are taking the 2 molecule of thiol. Or in place of this thiol we may take a dithiol also to get a cyclic acetal or ketal. This will give you the 5-membered cyclic dithioacetal. And if we are taking 1,3-dithiol, then we will get a 6-membered cyclic dithioacetal or dithioketal. So suppose if we are taking a 2 molecule of thiol, then we will get acyclic, this is acyclic dithioacetal or ketal. So this is one acyclic dithioacetal or ketal. So if this R is equal to H, then it is acetal. If R is equal to any alkyl group, both alkyl group are present over here, then that would be the ketal. So either we will get an acyclic one or we may get a cyclic one. If you are taking 1,2-dithiol, then we will get a 5-membered dithioacetal or dithioketal. So this is called as the 1,3. This is called as the 1,3-dithiolane. 1,3-dithiolane. If we are taking 1,3-dithiol, then we will get a 6-membered ring. So this is called as the 1,3-dithiane. It is called as 1,3-dithiane. Okay. So these are the different ways by which the carbonyl compounds can be protected in the form of acyclic and cyclic dithioacetal, dithioketals. Now let's see mechanism of protection and this deprotection. So if we have this carbonyl compound and suppose in place of any acid, we may take suppose if we are taking the Lewis acid, boron trifluoride ethylate, suppose if we are taking, and then so this lone pair will attack over this electron deficient boron, and we will get positive charge over this oxygen, and okay, now in next step, suppose if we have a dithiol, so this will be O, this double bond that is converted into single bond O, this is PF3 and such. Okay, now in next step is proton transfer where it takes place. Okay, now this group that will be removed and we will have okay. So now, so this will attack over this electrophilic carbon center and this positive charge is neutralized, and what we will get? We will get a cyclic dithioacetal. We will get a cyclic dithioacetal. This is 5-membered cyclic dithioacetal. So this is the way in which we may make a 5-membered, that is 1,3-dithio. In the same way we can protect in the form of 1,3-dithiene, that is 6-membered ring can be formed also. So this is the mechanism of this protection. Now in the same way we can do for the others also. Now let's see the mechanism of deprotection. So if you see mechanism of deprotection, so let's see for the deprotection. Okay, so suppose if we have cyclic dithioacetal or ketal, and what I told you, it can be deprotected by any mercury salt. So I am taking this HgCl2, this in presence of this H2, this can be deprotected. So this lone pair that will go into the d orbital of this mercury, and we will get and one of the chlorine that will leave out here. One of the chlorine will leave out and positive charge over this sulfur HgCl like this. Okay, now in next step, so this positive charge that will neutralized and this H2O being nucleophile will attack over this electrophilic carbon center. So what we will get? We will get now this ring is opened here. And this is one of this. Okay, so now so in next step, this H plus, this is removed from over here, and we will get OH. Now further this will attack in the d orbital of, this lone pair will attack over the d orbital of mercury, chlorine will leave out, and finally what we will get? We will get R H plus, and this will get precipitated. This mercury salt that we get, this will get PPT of this, that can be removed. Okay, and finally we will get the carbonyl compound. So in this way we can see this carbonyl compound is deprotected using this mercury salt. Okay, so this is the method of protection and deprotection. Now, if suppose we have more than one carbonyl groups are present in any molecule, then which carbonyl group that would be protected first? Okay, so let's see the selectivity of protection of carbonyl groups. So we have here discussed the various ways of protection of a carbonyl group. One is the acyclic one, another is the cyclic one. So one of the things that I want to tell, that this cyclic protection is much preferred over the acyclic protection. So why? So one of the things that I want to tell here, so this, you may note the thing here, this is cyclic acetal or thioacetal or thioketal is preferred. Cyclic protection is preferred, or cyclic acetal ketal is preferred over acyclic one, acyclic acetal ketals. So reason is the entropy advantage. So suppose if we are having the carbonyl compound and in presence of acid catalyst, and suppose if we have two molecules of this alcohol, then that will form a acyclic acetal ketal. So this will give you the acyclic acetal ketal. So this is acyclic one, plus one molecule of this H2 is removed. Now if you are protecting it as a cyclic one, if you are protecting it in a cyclic manner, then what we can see, what is the difference over here? Let's see the difference over here. So here we are getting the 5-membered ring, or we may get a 6-membered ring if we take a 1,3 diol. Okay, so if we see these two reactions, then here 2 molecules of alcohol is used. In reactants, this 2 molecules of alcohol and 1 molecule of carbonyl compound. So 2 molecules of alcohol and 1 molecule of carbonyl compound, this is giving you the 1 molecule of this acetal or ketal and 1 molecule of water. Okay, so whereas here if you will see 1 molecule of carbonyl compound and 1 molecule of this 1,3 diol, so it is giving you the 1 molecule of cyclic acetal ketal and 1 molecule of water. So here we can see the entropy is neutral. We can see 2 molecules are present in a reactant and 2 molecules are present in a product. So here entropy is neutral. Okay, but if you will see here, in reactant there are 3 molecules and in product there are 2 molecules. So here we can say entropy is negative. or here we can say entropy is less, here entropy is more. So the formation of cyclic acetal and ketals are preferred due to the entropy advantage. So cyclic acetal and ketal is preferred over acyclic acetal and ketal due to entropy advantage. So we should prefer the cyclic one, formation of cyclic acetal and ketal or cyclic thioacetal and ketal is preferred. Okay, so now let's see the selectivity of carbonyl compounds. Okay, let's see selectivity of protection of carbonyl compound. Selectivity of protection of carbonyl compound. Now, so in a molecule, suppose in a same molecule, if we have two carbonyl groups, then which should be protected? If in a molecule, if two different carbonyl groups are present, then which should be selected first for the protection? So no doubt the reactive carbonyl group is preferred first. Okay, so the carbonyl group which is more reactive is preferred first for the protection. So suppose if we have a different carbonyls, suppose if it is formaldehyde, so formaldehyde is preferred first, then suppose if we have acetaldehyde, and after that this suppose ketone. So if we have a formaldehyde or acetaldehyde in a same molecule, suppose if we have this formaldehyde and if we have acetaldehyde, then which should be protected first? This formaldehyde should be protected first, because this formaldehyde being more reactive than this acetaldehyde, then this should be protected first, and after and the reaction will go on over this acetaldehyde. Now after that, six-membered carbonyl, then five-membered carbonyl, and then after that is unsaturated, alpha-beta unsaturated carbonyls. So this is least reactive. Alpha-beta unsaturated carbonyl is the least reactive due to this resonance over here. This electron, this becomes the least electrophilic center due to this resonance. Okay. Now, so let's take a different example. Now, suppose if we have, let's take some example. Now, so what should be how the protection should be done, whether at this center protection should be done or at this center. So what I told you, this center is more electrophilic, that's why this should be protected in comparison to this. Okay. So this should be protected first, and the reaction will go on over this center. In the same way, now suppose if this is a molecule, so in this molecule we can see one of the group, this is the keto group is present, and another group is this ester one. So we know that this ester being the less reactive, so this is less reactive center, this is more reactive center, that's why protection will takes place over here and reaction will go on over here. So the protection will be done over this center. Keto is protected and this will remain unprotected. Ester will remain unprotected. Okay, in the same way, let's take another example. Suppose if we have now, if this is a molecule, suppose this is a molecule, then here we have two keto groups. We have a two keto group which should be protected. Okay, which should be protected. So now if you will see, then here this center, this keto is strictly hindered due to the presence of two methyl groups over here, and this is more strictly hindered. So this is strictly hindered, this is strictly free. So as this is strictly hindered, that's why the protection will go over here. So we can protect this carbonyl center. Okay, now in another example, suppose not this one, let's take this one. Okay, so we have two carbonyl groups. This is one of the carbonyl group, this is the another carbonyl group. Okay, so which will be protected? So no doubt this carbonyl group will be protected because this is alpha beta unsaturated carbonyl. So this alpha beta unsaturated carbonyl, this center being the less reactive, so this will get protected. So the product that we will get, this would be the product. So this will remain unprotected and we will protect this one. Okay, now in the same way, let's see some more examples. Now suppose if we have this alpha beta unsaturated ketone. Now in this case, suppose if this group is present in any molecule, then what will happen? Suppose if we protect it, then after protection, this double bond which is present over this alpha and beta position, double bond which is present at alpha beta position, so that will be transferred to beta and gamma position. Okay, this should be remembered. Now let's see the mechanism for this. Let's see the mechanism of this one. Okay, so if we see, then first of all, in presence of this acid, to generate an electrophilic center, this will get protonated, and now this diol, this nucleophile will attack over this electrophilic center, and what we will get? Double bond is present over here. Okay, now this is the OH and this is OH. Okay, now in next step, is proton transfer. In next step is proton transfer. Okay, and now this H2O, this is removed, and double bond will get transferred over here. This is in conjugation. So one of the double bond, new double bond is created over here, and a positive charge is created over here. Okay, and this oxygen OH. Clear? So after that, one of the hydrogen which is present over here, this positive charge is neutralized by the removal of this proton, and one of the double bond here, and another double bond over here. Now next step, this cyclization will occur, and now you can see this double bond is shifted over here. So this is the new beta gamma double bond. Okay, so similarly, suppose if we have this molecule, if we have this molecule, and double bond, this is alpha beta unsaturated carbonyl compound, and if we on protection, so what will be the product? On protection, the double bond which is present at this alpha beta position, that should be shifted to the gamma and beta gamma delta position. Okay, sorry, beta gamma position. Sorry, oh, it's okay. Okay, that should be shifted to the beta gamma position. So that will be shifted to this double bond. This will get shifted to the beta gamma position, and here this will get protected. Okay, so this is our gamma beta position, and this is the gamma position like this. Okay, now let's see some conversions. Now. Okay, now first one, suppose if we have two carbonyl group in this compound. Now if we want to convert this, into this one, so if you can see, then one of this carbonyl is converted into, one of this aldehyde group is converted into this acid group, and this aldehyde is remained unreacted. So to convert this aldehyde into this acid group, what we should oxidize it. Okay, but if we do the oxidation of this molecule, then both this aldehyde group will get oxidized to COH. So for this, one of this carbonyl that should be protected. So one of the carbonyl that should be protected. So what we can do, we can protect it. So this can be protected using this one equivalent. Suppose if you are taking one equivalent of this dithiol, then this will get protected and this will remain unprotected. Okay, and in next step we can oxidize this one. So suppose if you are taking oxidizing agent, potassium dichromate, and then this will get protected, and now after, sorry, this will get converted into this acid. And now after this conversion, now this can be deprotection. So this will be deprotected using this mercury salt. We can deprotect this cyclic dithiaacetal. So this is deprotected, and we have got the desired product. We have got this desired product. So this is one of the example. Now let's take another example. So suppose if we want to convert this, okay, so if we want to convert this one into, alcohol. Okay, so in this molecule, as you can see, this one of this ester group is converted into this alcohol. And this keto group, this carbonyl group, remain unreacted. So how can we do this one? So this ester can be reduced to this primary alcohol, and if we use any reducing agent, then this carbonyl group will also get reduced into the secondary alcohol, and this ester group will get reduced to the primary alcohol. So to do this one, to get the desired product, we should protect this one. So this can be protected. First of all, what we will do, we will protect this carbonyl group, and then we will reduce this ester group. So this one this will get protected. So now, so this is protected, and this will remain same. This ester group will remain same. Okay, this ester group remain same. Now we can use any reducing agent. Suppose if we reducing agent, suppose a lithium aluminum hydride is used as a reducing agent, and this after that it can be hydrolyzed. It can be acid hydrolysis. So what we will get? We will get this remain protected, and this will get converted into this alcohol. This will get converted into this primary alcohol, and in next step this may be deprotected. So deprotection using this mercury salt, this can be deprotected. Okay, so we will get this desired product. Okay, now let's see another example. So in next example, suppose if we want to convert this one into now, as you can see here in this example, this ester group is converted into this acyloxy group, and for this how we will do it? To convert this into this acyloxy group, we can first convert this ester into alcohol, and alcohol can be acylated to convert this into acyloxy group. Okay, so if we convert it into alcohol first, if we convert this one into alcohol, or if we reduce it into the alcohol, then this carbonyl, this keto group will also get reduced to the secondary alcohol. So that's why first of all we should protect this carbonyl group. So protect this, being the more reactive, this will no doubt it will get protected. So first of all we will protect this one. Using suppose 1,2-dithiol, and that will get protected. This will get protected, and this will remain as such. Ester will remain as such because this is less reactive, this is more reactive, so this will get protected, this will remain as such. Now in next step we can do the reduction. And followed by this acid hydrolysis. Now this will get reduced to the alcohol. this OH. Okay. Now next step. In next step, what we will do? Now this should be converted to we should have this acyloxy group here. So that's why this can be acetylated using this acid chloride. That can be acetylated, or acid anhydride that can be acetylated, and we will get this O and this one. Okay, and finally this can be deprotected. And we will get the desired product. Okay, so we will get the desired product. So these are some of the conversions. Okay, thank you.